Hi everybody. Today we're going to do lesson 7-13 and that is going to be factoring binomials. So for quite a few days we've been working on factoring trinomials, but actually when we first started we did do some binomials, so I'm going to remind you of that. It's GCF, greatest common factor, is what we're going to use. So just as a reminder, something like 2x squared plus x, well, what comes out? What's common in both of them? I have an x here and an x here. That means the x can come out. What's left over after I divide by x is going to be a 2x. Let me just show you. This x becomes x to the first because this one goes away. And this is x divided by x. X divided by x is a 1, okay? And we have a, oh, well, it was a 1. It wants to be a 1. It is a 1. There you go. Okay. That's GCF factoring. You just factor out or divide out the common factor of both of those two terms, binomial. All right, so let's do another one real quick. We're going to do this one, 4x to the third and 5 minus 5x squared. Okay. All right, so look at the letters. We have x to the third and x squared. We can take x squared out of both of them. So we do that. Now we have to look at our numbers, 4 and 5. There's nothing we can do with those. Okay, so we are going to pull out the x squared. And what we have left over is 4x minus 5. Okay? Last one, 3x squared plus 6x. Well, I definitely have an x in common, just x to the first, or x, and I can take out a 3 from each of these terms also. 3 goes into 3 evenly, and 3 goes into 6 evenly. So we're going to, our greatest common factor is 3x. What's left over after we divide, you change that, is going to, the 3's cancel out. You get an x to the first here, because this x goes away, so that's an x. Cancel out the x's on the second term, and 6 divided by 3 is 2. So our answer is, I'll put it all in one color, 3x parentheses x plus 2. Okay, so that's GCF factoring. GCF factoring can be done with trinomials sometimes, and it could be done with binomials. It could be done with any polynomial, actually, that has common terms. All right, so the new thing that we're going to talk about today, let me just erase this board. The new thing we're going to talk about today is called difference of perfect squares. Okay. Difference of perfect squares. Okay. So the first thing we're going to do is just jot down our the perfect squares that we should know. At one time, I think we all knew them, but we want to make sure that we have them, you know, in our pocket here and ready to go. So what you're thinking is 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7, 49, 8 times 8, 64, 9 times 9, 81, 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144, 13 times 13 is 169, and 14 times 14 is 196. You realize that's 169 and then 196. It's the only way I remember it. And then 15 times 15 is 225. Look at that, perfect number of lines. Okay, so those are your perfect squares. So here's what a problem that is talking about difference of perfect squares would look like. If I had something that said x squared minus 4. Okay? Well, that x squared, do we all remember that x times x is x squared? So x squared is a perfect square. Okay? X squared is a perfect square because x times x equals x squared. So x squared is a perfect square, 4 is a perfect square, and this is the difference of perfect squares. All the difference means is subtract. So really what they're saying up here is the subtraction of perfect squares. Subtraction of perfect squares. So the first thing you have to notice is it going to be subtraction? In this case, obviously it is. We're going to double bubble like we do with our trinomials. Double bubble. And we are going to say, well, the square root of x squared is x, right? X times x equals x squared. So we're going to do an x in the front of each of the bubbles. So x times x is x squared. Well, what times what is 4? 2 times 2 is 4, right? So the square root of 4 is 2. We're going to use the square root of 4 in the back of each one of these bubbles here, or parentheses. Now, in order to get negative 4, you have to have two different signs. So the format is going to be the first bubble gets a plus and the second gets a minus. And actually, you can change it. The minus can come first and the plus can come second, but whatever. It's x times x is x squared, 2 times 2 is 4, and a positive times a negative is a negative. That's what we're doing there. So that's example 1. Okay? Now, I'm just going to give you a counter example to example 1. All right? If I have something like x squared plus 4, I have to stop right there. That is not the difference. This is addition. Okay? So it's not difference. Not a difference. Okay, so that's that. So let's do another good one. I promise you this one will work. So let's do number 2, example number 2, and that's going to be y squared minus 81. Okay, so if x times x is x squared, y times y is y squared, right? So the square root of y squared is y. Okay, so what I'm going to do in this one, I'm going to actually put the square roots around it. So we're going to take the square root of y squared and put it in the front of each set of parentheses, each bubble. We're going to take the square root of 81, which if you look down your list there, 9 times 9 is 81. So we're going to use a 9 and a 9. And then what we have to worry about is this guy here. We really want it to be a negative 81. So it's going to be a positive times a negative gives you a negative 81. And that's going to work every time. That's going to work out that way every time. If you have the difference of two perfect squares, you will have a plus and a minus for your signs. Let me do the third one. All right, number 3. A squared minus 36. I don't know if you can hear that. That's my dog scratching the floor. Okay, so we're going to look at this. It's a squared, so that's a perfect square. Then you have minus, which is subtraction. That's what we want. And then 36. Well, 36, if you might know it already, or if you look in your list, 36 is a perfect square. So we are going to double bubble. Square root of a squared is a. So a times a equals a squared. On the back end, we're going to do square root of 36, also known as 6 times 6 is 36, okay? Now, we need a negative 36, so we're going to put an addition and a subtraction. And that's it. Ooh, I haven't been boxing my answers. Box, box, and box. All right, I'm doing one more with you because this should be fairly simple, I think. So this one's going to be just a little more advanced, and but it's something that you're definitely going to be seeing. Let me see. Oh, it's 16a squared minus 25. Okay, so we have to kind of take this one little step at a time here. First of all, 16 is a perfect square because 4 times 4 is 16. A squared is a perfect square because a times a is a squared. 25 is a perfect square because 5 times 5 is 25. And so, and we have a negative there, so we want to have in our bubbles, we want to have a positive and a negative because negative means difference. So we have a difference of perfect squares. So we're going to take the square root of 16 is 4, but it has an a squared attached to it, and the square root of a squared is a. So in the front of each bubble, you put a 4a, okay? Because 4a times 4a would equal 16a squared. That's an a, okay? In the back, we're going to put a 5 and a 5, a 5 and a 5. That's because the square root of 25 is 5. But now we have to think signs. Well, a positive times a negative gives you a negative. So 5 times negative 5 is negative 25. Okay? So that's it for new stuff. I'm going to give you a couple of problems to work out on your own. Do them on your own. Don't copy my work. This is so simple. You can't really, you shouldn't bother just copying me. Okay, so here are your 4 practice problems. Please pause and then try out these problems. And when you come back, the answers will be up. Okay, so here are your answers. Hopefully you were able to get most of these, if not all of them, correct on your own. So that's it for today. So I will see you next video. Well, you'll hear me next video. Take care. Have a good day.